What is the frequency of a light wave with a certain wavelength? Now remember, all light waves have got the same speed, and we know that v is equal to lambda f. And if v is going to be equal to lambda f, then we're able to say 3 times 10 to the power of 8 is equal to, I've been given a wavelength, and it's 420 nanometers, so that means it's times by 10 to the negative 9. And then I simply divide through, and I land up with 7,14 times 10 to the 14. What is the energy of a photon of light that has that exact same wavelength? So I've now already got the frequency of that, and I know that energy is equal to HF, and H is equal to 6,6 times 10 to the negative 34. And that is multiplied by frequency, which is going to be equal to 7,14 times 10 to the 14, and we land up with an answer of 4,7 times 10 to the negative 19. What is the wavelength of a light wave with a frequency? So this time I've been given the frequency, and again, frequency, if I rearrange this equation over here, frequency is equal to the speed divided by the wavelength. This time they've asked me for the wavelength. So wavelength is equal to the speed divided by the frequency. So it's going to be 3 times 10 to the power of 8 divided by the frequency that they've given, which is 7 times 10 to the 14 hertz. And I land up with 428 nanometers. I actually land up with 4,28 times 10 to the negative 7, I think, but it comes out to 428 nanometers. What is the frequency of light wave with 800 nanometers? So again, rearranging that equation, I'm going to go frequency is equal to speed divided by wavelength. They've given me a wavelength of 800 nanometers, so it's going to be 3 times 10 to the power of 8 divided by 800 times 10 to the negative 9, because it's nano, and I land up with a frequency of 3,75 times 10 to the 14. What is the energy of a photon of light with at same wavelength? I've worked out the frequency now, so energy, remember, is equal to HF. The H is going to be 6,6 times 10 to the negative 34, multiplied by the frequency that I've just worked out, which is 3,75 times 10 to the 14, and I land up with an answer of 2,49 times 10 to the negative 19 joules. Packages of light are called photons of light. So they are the little parcels of energy in light that travel in a wave-like pattern in the dual nature of light.